Hello, everybody. I'm Isaac. I want to show to us how we carry out multiple linear regression analysis using RStudio. In my previous videos, I talk about how to use the same IDE, that is RStudio, to carry out a simple linear regression analysis. But this is the data I'm going to use for multiple linear regression. The only difference between multiple linear regression, as I've told you in the previous video, is in the number of independent variables. For simple linear regression, we have just one independent variable. That's the predictor. But in multiple linear regression, we have more than one. Here we have three. This data set measures the effect of user load and API usage on the response time of a web or mobile app. It focuses on analyzing how the number of users, session, and API calls impact the speed of app. So what we want to do here, we want to see how number of users, number of session, API call per session affect the app response time, meaning that all these three variables are independent. We are the predictors for this response variable. So we have x1, x2, x3, y. So these are the questions. Create a multiple linear regression model to predict app response time based on number of users, session, and API calls. Number 2, evaluate the model and explain which independent variable has the most impact on app response time. And the third one is predict the app response time for an app with 90 users, 170 users, sessions, and 35 API calls per session. So we want to be precise here. What's going to be the app response time for these three values? This can only be done after you have come up with your model. So let's go to the IDE RStudio. So I have the data here. There are two ways. The data is the data is here. I can export it from this place through Excel to RStudio. And at the same time, I can just list it like this. Now, the library I put here, ggplot, I think I will need it. I may not need it. Right? It's a library meant for sophisticated charts. Now, create the data. We have done this. We have all this. So data frame is the one that combines the data together. So just run this. When you run this, you can now see the data in the table. Data frame has given us that. See, this is the table. And if the data is so complex that you can't see, you want to see which of these variable names, and it's so long that you have to scroll. Don't need to be scrolling. Just in names of, those are the columns names or the label of the variable. If you quickly give it to you, you can see. I see the first variable, second variable, third variable, and fourth variable. So here, the response variable is the last one here. It can be anywhere. It can be in the middle, it can be at the beginning. Now, guys, I have a lot of things here. So let me clear the console, Control L, for you to see better. Now, I have, next thing to do here is to model. I want to model it. So build a multiple linear model regression. This is the model. If you look at this model very well, the only difference between this model and that of simple linear, is the number of independent variables that we have. There are three here. So you have, after the first one, U plus, you instruct R where to get the data. The data is app data. You can see data is equal to this. Then you build the model and summarize it. So this is it. This is the model. And see, this is the summary of the model. So you can write out this model out. Y equals, how you normally write it. Y equals beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, and so on. So this is the model. You can write them out. You can see R is very good when it comes to computation. C, number of session, significant, 1 star. API cost per session, 3 star. So the most significant independent variable here that contribute most to duration, the response time is the API cost per session. You can see 3 star, 0.0000. You are rejecting each not for these two, but number of users is not significant, though it contributes also 0.37. So far you don't have 0 here. That particular factor is also contributing. That's what it means. Now let's come to R square. The adjusted R square is 0.9964. This means that 99.6% of the variation in the response variable is explainable determined by the model. The model can explain 99.6 variation of the response variable. So it's a good model because the closer this value to 1, the better your model. We call this one coefficient of determination or goodness of fit. And p-value here is 0. This is 2.8 raised to power 8. That's 0.0000. You can see 2899. This is a very good model. It's highly significant. What other thing can we do? We can visualize. We do okay before visualization. Let me see the question here. Evaluate the model and they explain the independent variable that's the most impact. We have checked that. And the third one is what we are doing now. We want to predict the app response time for app when it is 90 user, for session when it is 170 session, for API when it is 35. We want to determine that. Of course, you can do that even in mathematics. You need to write out the equation out and include this value and work them out. But we are using R, you can do it directly. All you need to do is just predict is a function in R. Predict is a function in R we can use. So the model this is the model you have evaluated. So this is the new model. This new data we have this one is from the question. Number of user is 90. Number of session is we want to predict what will be the app response time with these three values. So you have to create another data set. So I've created it already. I want to show it. This is it. You can see number of user 90, number of session 170, app cost per session 35. So all you need to do is just bring them here. So we use predict. So predicted response now. The model which I've done, put it here. The new data here. You are asking now to predict the value of app response time using the existing model. That is it. So we now run it. So that's 208. You can see your app response time at this time is 208. Let's go and check whether it's sensible. 208. You can see when it is 90 here, it's 170 here, 70 here, then it's 835. So the corresponding value here is 210, and we are getting 280. Very close to it. It's a very good model. See? Now, can we visualize it? Well, scatter plot is very, very good for simple linear regression. But when it comes to multiple linear regression, scatter plots, only one may not be okay because we have more than one. But you can do what you call scatter matrix, scatter plot matrix, or pair-wise scatter plot. So we are going to, because we are going to have more than one. This is the code. This is the function. PS is going to bring all the 4 variables together and show the relationship, the linear relationship. So let's run it. You see, let me zoom it. You see now. So you can easily see how the relationship exists here among the 4 variables. See number of user. So how do we interpret this? Very easy. So this is anywhere you see this. Now this one, when you look at this now, this is y-axis here. X-axis is number of session here. So the relationship between number of users and number of session is linear. And the relationship is positive and very, very close to 1. You can see the points are not too far away from linearity. Yeah, and if you want to be comparing each of them with the response variable, which makes sense. So this is going to be the horizontal axis. Y this is going to be the x-axis. This one here will be the x-axis here, and the y-axis here, and this will be the x-axis here, and so on. You can see all of them are linearly related, and the relationship is positive, and it's very close to 1. In case you have another question you want to ask me in the question, meet me in the next class. Or you drop your question on the site, or send me a mail. Make sure you go over this